In this video, you'll learn how to create a simple API using the Symfony PHP framework. This will include all the RESTful API endpoints, along with validation, persisting the data to a database, and exception handling. I'll be doing this using raw Symfony instead of the API platform framework. To follow along, you need to know how to use Symfony and have PHP and Composer installed. I cover all you need to know in my Learn Symfony in 1 hour video, and there's a link to that video in the description. Let's start by creating a new Symfony application. I've got the Symfony binary application installed, but you can do this using Composer if you prefer. The details of how to do that are in the official documentation. I'll call the application Product API. Note I'm not including the web app flag as I want to install any extra packages we need manually. This has created a folder called Product API. Let's change into that folder, then use Composer to add some extra packages. To work with the database, I'll install the ORMPack package. Note that as I'm using Symfony Flex, I can use this alias. After installation, this asks if we want to include some Docker configuration. I don't want that for this video, so I'll enter X to not ask again for this project. As recommended by the installer, we need to configure the database in the .env configuration file. In that file, I'll comment out the Postgres line and uncomment the SQLite line, so locally this project will use an SQLite database. You can of course use a different database if you prefer. Just make sure you configure the relevant URL in here. Next, let's create an entity class to represent a table in the database. Instead of creating this class manually, let's generate it. To do that, we need the maker package, which we can install using Composer. I'll include the dev flag as we only need this package for development. Then we can generate an entity class called Product. Let's add a property called Name. That's a string of 128 characters that can't be null. Then a property called Size, which is an integer which can be null. Following this, another property called isAvailable, which is a Boolean value which can't be null. Finally, a property called PublishedOn, which is a date that can be null. This is just so we have some fields of different types so we can see how these work in the API. To stop adding fields, I'll just press Enter. Before we create a migration to generate the code to create the database table, in the entity class we just generated, let's add a default value for the isAvailable property. Let's also set the default value of the property to true as well. Then, back on the command line, let's generate a migration for this entity. Then run the migration to create the table in the database. Next, let's generate a controller to handle the API requests. I'll generate this controller class inside the API namespace. Note we need to put 2 backslashes, as 1 backslash would be interpreted as an escape character. If you have Twig installed, then along with a template being created, the controller class that's generated will include a method that renders that template. If you don't, or if you include the noTemplate flag, then Symfony assumes you're creating an API, and the generated method will render a JSON response. I don't have Twig installed, so I don't need to specify it. When asked if I want to generate tests, not for this tutorial, so I'll reply no. Note that this has generated the controller class in a subfolder called API. In that controller class, note the API namespace has been added to match the subfolder. The Symfony JSON response class is included, which is used as the return type declaration for the index method. This ensures the correct response headers are set, which we'll see in a moment. In the body of the method, some simple JSON data is returned. To test this, first let's run the local development web server with the Symfony serve command. The web server is now listening at this address. To make requests to the API, I'm going to use http on the command line, as it's simpler than curl and clearer than Postman for tutorials like this. I'll leave the web server running and open a new terminal window to make the requests. Note that the index method in the controller has been generated with the root /API/product. Let's change this to /API/products. To keep this simple, I'll also remove the generated name as I won't be using it, but you can keep it in if you like. I'll also restrict this root to only responding to the HTTP GET method, as later on we'll add a root that uses the same URL but a different method. So let's make a GET request with HTTP to that path on the local development server. We get a 200 OK response with the JSON content type header. The response body contains the simple JSON data. Note that GET is the default in HTTP, so you don't need to include it, but I'm leaving it in so it's clear which request method is being used. Let's change this so we're returning data from the database instead of this literal JSON data. To do this, let's get an entity manager object by adding an argument to the index method, type hinting it with the entity manager interface. This requires a use statement to import it into the current namespace. Then, we can get an instance of the product repository class that we generated earlier when we generated the entity by calling the getRepository method on this, passing in the class name of the product entity class. To use the product entity class like this also needs a use statement. Then, to get all the product records, let's call the findAll method on the repository, assigning the return value to a variable. We can then replace the literal array with this variable. Let's repeat the API request, and now in the body of the response we just get an empty array. This is to be expected as we haven't added any data to the database table yet. To add some data to the database, let's add some fixtures. To do this, let's use Composer to install the ORM fixtures bundle, making sure we include the dev flag. Then, in the Data Fixtures folder in the Source folder, in the App Fixtures class, we can add some data to the product table. In the load method, let's create a new object of the product entity class, including the associated use statement. This is already included but commented out, so we can just remove the comment. Then we can use the entity setter methods to set values for the name, size, and published on properties. The isAvailable property has a default value, so we don't need to specify one for it. To save this object, we call the persist method on the object manager, passing in the object. Let's add another product, this time with different values for the name, size, published on, and isAvailable properties. Again, we'll follow this with a call to the persist method to save it. To actually save these values to the database, we need to call the flush method, which will load them into the database table. Before we run this, let's not forget a use statement to import the datetime class into the current namespace. To run this, we use the doctrine fixtures load command. Note that this will remove all data from every table in the database before it runs. If you want to just append the fixture data, you can specify the append flag. My database is currently empty, so I won't include that flag. Let's run that and confirm that action by typing yes. We can confirm that we have some data in the database now by running a query in the console, selecting all the records from the product table, and there we see the two records. So now let's make the API request again, and we no longer get an empty array in the response body, but the contents of the array is just two empty JSON objects. In the controller, we're using the findAll method of the repository to get the product data. This returns an array of product entity objects. When this is converted to a JSON response on the next line, by default, the framework doesn't know how to convert these objects to JSON. This is where the Symfony serialiser comes in. We can install this using Composer by installing the serialiser pack. Now that's installed, let's make the API request again, and now we get the product data in the response body. The controller will use the serialiser automatically once it's installed. By default, all the values of any public properties and return values from any public getter methods are included. The keys in the JSON object are generated automatically, for example, size. One way to configure the serialized output is to use attributes. Here in the product entity class, let's add the serialized name attribute to the size property, specifying a string argument of bigness. To use this class like this, we need a use statement to import it into the current namespace. Now when we make the API request, the key for the size column has been changed. The serialiser can also be configured from the controller. First, let's pass in an argument to the index method to get the serialiser service. We'll type hint this with the serialiser interface, which needs a corresponding use statement. Then, to turn the array of product objects into a JSON string, we call the serialize method on this, passing in the array of objects, and a string to specify the JSON encoder. Then, as this returns a string containing JSON, we can't use the JSON method of the controller as this will encode it again. Instead, we can use the static fromJSON method of the JSON response class to generate a suitable response. Let's try that again, and we get the same result as before. Note that the attribute we used in the entity class is still being used. Now we have access to the serialiser object being used, we can configure it directly. The serialiser uses a class called a normalizer to convert the object into an array. In this case, it uses the object normalizer. Let's configure this to remove an item from the output. So let's add a third argument to the serialize method call, passing in an array containing an element that configures the ignored attribute property of the normalizer. In this case, let's just specify the ID attribute. And of course we need a use statement to import this class into the current namespace. Now when we make the API request, the ID attribute for each product isn't included. There are many different configuration options for the serializer used to convert the object to JSON. I won't go into them more here, as that's the subject for another video. Next, let's add an endpoint to retrieve the details for an individual product. We'll add a new public method called show that will return a JSON response. Let's add a route attribute for this, specifying a route that includes a variable for the ID, and restricting this to just the HTTP GET method. To get the product record with this ID, we can use the entity value resolver by specifying an object of the product entity class as an argument. Then, in the body of the method, we can output this as JSON as we did originally in the index method above. Let's give that a try, making a GET request to the endpoint we just added. That works, and we get the data for the record with an ID of 1 in the response body. Let's try that with a different ID, and we get the data for that record. Next, let's add an endpoint to create a new product. So in the controller, let's add a new public method called create. In here, we'll need access to the request so we can get the data to save. We'll need access to the serializer to convert the supplied JSON data into an object, and access to the entity manager so we can actually save it to the database. As with the other methods, this will return a JSON response. For the request class, we need a use statement to import it. In the root for this method, let's use the same as the index, but specifying the HTTP post method. In the body of the method, first let's get the content of the request. As with the response returning JSON data, the API is going to accept request data as JSON too. So we can use the serializer to deserialize the JSON content into an object of the product entity class. Then we can use the entity manager to persist that object, then calling flush to write the changes to the database. Finally, let's return the product object, encoded as JSON, with a 201 created status code. Let's try that by sending a POST request to the /API/products path. To send JSON data using HTTP, we just pass key value pairs at the end of the request. To pass an integer, we put a colon before the equals sign. When I send that request, we get a 201 response with the details of the created resource in the response body. This includes the ID of the record that was created. So we can make a GET request to the endpoint that shows an individual resource, specifying that ID, and we get a successful response. This shows the previous request to create the resource was successful. Let's try the same POST request in Postman. To send JSON data in the request body, in the Body tab, select the Raw option, then JSON from the drop-down list. In the request body input, we enter some valid JSON data. Let's send that request, and we get the 201 created response. Next, let's validate this data before we save it to the database. First, on the command line, let's install the validator. Then, in the product entity class, let's add a use statement to import the validator constraints with an alias of assert. Then we can add some attributes to the properties for the validation. Let's just add a couple of examples. So let's validate that the name isn't blank and that the size is positive. Then in the controller, let's add an argument to the create method to get an instance of the validator from the service container. And this of course needs an associated use statement. Then, once we've got a product object, let's call the validate method of the validator, passing in that object. If the resulting array of errors isn't empty, then let's return a JSON response containing those errors with a 422 unprocessable entity status code. Let's give that a try, posting a request with an empty name and a negative integer for the size. The response we get has a 422 status, and the body contains the error output from the validator in JSON format. There's quite a lot of information here, and for an API like this, you probably don't want all of this data. So you could do something like this, to just get the property and the associated validation message, looping around the array of error details, and just extracting the name of each property and the validation message. Then, instead of returning the errors array, just return the array of error messages. Let's try the request again, and now we just get the fields and the validation messages. If I pass in valid values, then the validation passes, and we get the 201 created response as before. Next, let's add an endpoint to update an existing resource. So let's add a public method called update. This needs the request object, the product entity we're modifying, the serializer to get the data from the request, and the entity manager to save the data to the database. This will return a JSON response. Let's add a root attribute to this, including a variable for the product ID and specifying the put and patch methods, so you can use either. You can of course just specify one of these methods if you prefer. Inside this method, we can deserialize the content as we did above. This time, however, let's add an argument to this, specifying that we want to populate the product object argument with the deserialized values. This will overwrite any property values in the existing product object with the values from the request. We can then call the flush method on the entity manager and return the product object as JSON. I won't include the validation code in order to keep this video simple, but validation would be done in the same way as in the create method above. Let's give that a try. First, let's get the product with an ID of 2 to see what values its fields contain. Then, let's update that with a patch request, changing the name to another value. We get a 200 response, with the response body containing the updated product resource. Next, let's add an endpoint to delete an existing resource. So let's add a public method called delete. This needs the entity manager and the product entity, and will return a JSON response. For the root, we'll include a variable for the product ID and specify the HTTP delete method. In the body of the method, we can simply call the remove method of the entity manager, passing in the product object, followed by the flush method. As a response, we'll return null with a 204 no content response code. Let's give that a try. If I make a GET request to get the product with an ID of 2, then we get a 200 response. If I change this to use the delete method instead, then we get the 204 response with an empty response body. So now if I make the same GET request, we get a 404 response. Note that this response is in HTML and is very long, so this is just the top part of it. It's in HTML because HTTP doesn't send the request accept header containing the JSON content type by default. However, you can force this with the J flag. Now we still get the 404 response, but the response is in JSON. So we can confirm that the resource has been deleted. Note that in production, this output would be much simpler, without all this debugging information. In Postman, if we make the same request to the resource that we just deleted, then we also get the 404 response with HTML in the response body. To set the request accept header to JSON, go to the Headers tab, and then add the accept header, and set its value to application/JSON. Now when we send the request, we get the 404 response, but with JSON in the response body. So the framework will automatically respond with the relevant content type based on this request header. If you prefer to always respond with JSON, no matter what the request is, then one technique to do that is to add a listener for exception events, and control the output from there. So on the command line, let's generate a listener class and call it exception. When running this generator, you can specify the event you want to listen to as the second argument, or if you omit it, you'll be prompted to choose one. When prompted, let's choose listener and choose the kernel exception event. This has generated an exception listener class in the event listener folder. That class contains a method that will be executed every time an exception occurs in the framework. So what we can do in here is to change the response to JSON. So first, let's get the exception object with the getThrowable method on the event argument. Then we can create a JSON response with a body that contains the message from the exception object. Note, we also need a use statement to import the JSON response class into this namespace. Then we can replace the event's existing response with this one. Let's try requesting the product that we just deleted. And now the response we get has the JSON content type, and the only value in the body of the response is the error message. Note though that this changes the response to JSON for all exceptions. For example, in a browser, if we go to a URL that we know doesn't exist, but that isn't part of the API, we get a JSON response saying no route was found. If your application combines regular web pages with an API, you might want to restrict the code we just added to requests to the API. A simple way to do this is to check the URL. So, before we generate the JSON response, let's get the request object from the event, then get the path from the URL. If this path doesn't start with /API, then we'll just exit from this method with a return statement. Now in the browser, the page that previously returned a JSON response shows the standard Symfony exception page using HTML. Requests to the API that cause an exception to be thrown still return the custom JSON response we added. So that covers the RESTful API endpoints for a simple API in Symfony. All the code shown in this video is freely available, and there's a link in the description. Many thanks to all my supporters on Ko-Fi, and as always, thank you for watching.